So in this last part of Chapter 11, we're going to look at how to chemically control microbes. And so one of the things we want to note, this picks up, if you move over, this is objective, number 14 as we kind of move into chemicals. So some desirable qualities that we look at with chemicals is we look for them to work quickly at low concentrations, because we know the higher concentration that could potentially harm us. We need them to be broad spectrum, because a lot of times when we're using chemicals on surfaces or things like that, we know there may be a lot of different types or different species of microbes, and so we need them to be very broad spectrum. We need them to quickly do their job, be non-corrosive, be non-staining, and then of course it's all about the Benjamins, right? So we also need them to be affordable. We need them to be readily available. And so when we look at chemicals, we have three levels that we kind of look at them at. So we have the high-level germicides. These are those that sterilize. We call them sterilants. They're going to kill everything. The problem with these is they also could damage body tissues. So the high-level germicides we typically don't use in reference to the body. You have intermediate level, so these are going to kill a majority of things. They're going to kill fungal spores, but not endospores. They're going to kill a lot of the bacteria. They're going to inactivate a lot of viruses. Again, this one's typically used for disinfectant areas. And then low level, these are going to kill a lot of the vegetative stuff. These can be found on the surfaces of your skin, not necessarily in your body, but on the surfaces of your skin. So in your book, there's a really good table, table 11.6, and it's going to hit on a lot of these chemicals. It's going to look at what they're going to target, it's going to look at their level, and then it's going to give you a couple of extra things about it. So this will be a really good table to kind of look at as you're studying through these things. I would strongly advise using it as far as that's concerned. So these are our major categories of germicides, so major categories of chemicals that we're looking to kill things. And again, we're going to work through these one at a time. So we're going to start with the halogens. So halogens are typically very germicidal. So these are killers. And so in the category of halogens, one of the first things we find is we find chlorine. So chlorine, we think of bleach, right? If you don't have bleach at your house, you need to have it at your house because it's a great agent for denaturing proteins. It's a good killer. The problem with chlorine is it's photosensitive, right? So it's unstable in the sunlight. It becomes inactivated in that sense. So we have to be really careful of it. So we use bleach with a lot of different inanimate objects. So definitely not something you'd use on body surfaces, but something that you could use on other surfaces around you. They also mention iodine under the category of halogen. I know a lot of you, when you think iodine, you think betadine because that's used a lot in healthcare. Again, this one deals with damaging proteins. It is intermediate, so it can be found on the surface of your skin, not internal. Again, used in a lot of medical fields, a lot of dental fields. It is a disinfectant, and so very good in that category. So again, you can kind of see some applications of some of the other types of halogens that we see. And again, something that's used in the food industry as well that you may not be aware of, that halogens are applied to certain types of foods to kill things like salmonella and other bacteria from spoiling or damaging foods and potentially damaging humans that consume them. And again, we see the addition of betadine and things like that to the body. So a second category we look at are the phenols. So phenol is a very poisonous compound. It disrupts cell membranes, it disrupts cell walls, it can also damage proteins. It's typically low to intermediate level, but it is a killer. So it can kill bacteria, it can kill fungus, it can inactivate some viruses. So it's a good example of phenols that you could think of would be like Lysol is a good example of a phenol. Certain types of soaps would be examples of phenols. So a lot of phenols, you have to be careful though because they are very poisonous. So if you're using them as an antiseptic, using it to clean body surfaces, you have to be careful because there is that potential, because they target cell membranes, that it could also damage your own cells. So they give you some examples that can be found with that. And you again see the table here. You can spend a little more time if you want to look through some specific examples of the phenols. And if you want to look at that check, you can. So we also have the alcohols. So a quick thing with the alcohols, this is going to be like ethyl and isopropyl alcohol. These are the main ones that are suitable for microbial control. They're intermediate level. And so what you're looking for is a concentration of 50% or higher. So like when you look at alcohols that you buy from the store, they'll tell you their percentage of concentration. So if you want it to be effective against a lot of microbes, it's got to be 50% or higher. And typically on the higher range, the stronger the concentration, the more dangerous they are to microbes. And so you see a great example of where some of this is used in antisepsis and things like that. We also mentioned hydrogen peroxide. So the great thing about hydrogen peroxide is it mentions it produces highly reactive radicals that damage proteins, can also damage DNA, while at the same time decomposing to an oxygen gas. And so one of the things that we notice when we apply hydrogen peroxide to like a wound, it produces those bubbles. So it's actually giving off oxygen, which is a good means that there was something there, and it's able to damage them or to kill them. So definitely hydrogen peroxide is an option with that. They also mentioned used in disinfecting contact lenses. So a lot of the cleaners we use are peroxide based, which is why you see the bubbles when you put it in these contact lens containers. So definitely noting when you see the bubbles, it's releasing the gas where it has actually destroyed a microbe and reduces them to that gas. Again, some examples here. So we also look at the aldehydes. So the good thing about an aldehyde is that they are very alkalytic. So we think of the fact that they can destroy proteins, they can destroy DNA. And so the first one on the list you may not be as aware of, but I'm sure you've heard of formaldehyde or formalin, preserving agents that are used in embalming or used in dissections. And again, they're added there to disinfect, to persevere, but they can be toxic, so you have to be careful in how you use the aldehydes that are there. But they can be used with equipment and things like that. They also mention the gases and the aerosols, so the things that obviously that you would spray. We can use them to sterilize, to disinfect plastics, prepackaged devices. We can also use aerosols and things like that in food as well. So you can see kind of how that's used in prepackaged things. Again, some examples that you can look through. And then they also look at detergents and soaps. So detergents, typically what detergents are going to do is they're going to target cell membranes. They're going to cause the cell membrane to lose its permeability and in turn to destroy the bacteria or the fungi. So we think about detergents like dish detergent or clothing detergents. Soaps are going to do similar things. Soaps are going to try to mechanically remove the soil, remove the grease that contains the microbes in it. One thing you have to know about soaps is, though, that they're weak microbicides. Why are they weak? Well, think about what we typically do with soaps. We typically put those on our body surfaces, and so it can't be too concentrated, can't be too strong, or it would actually harm our body. So again, chart here to kind of look at that. And so one of the last things they mention are the heavy metals, and so not to spend too much time here. So heavy metals, they mean like silver, mercury, they can kill vegetative cells. One of the things you have to be careful of with heavy metals, though, is a lot of times it'll trigger allergic reactions, because you know a lot of people are allergic to metals and things like that. So definitely something you have to kind of be careful with as far as using this as a control method. And then they also mention dyes, and we'll finish up with acids and alkalis. So dyes here, biggest thing with dyes in control methods is identification, right? We use gram dyes to identify species of bacteria, to identify them so that we can know what we're dealing with, so that we can target them correctly. So dyes are added as an agent of control for identification purposes. And then with acids and alkalis, remember, most microbes are going to prefer pH of 6 to 8. So if you can add them to a strong acid or something that's a strong alkaline or base, you can inhibit their growth as well.